the strange interstellar object whisked through our planet. Scientists have been on its trail for months. We now know objects can travel from one star system to another, and now they voiced out that the interstellar object is moving at an alarming speed and will crash in 2 weeks. Where, when, and what will be the aftermath on our planet? Join us as we uncover a lot more about Oumuamua. The emergence of Oumuamua. Oumuamua entered our solar system from the rough direction of the constellation Lyra, but it's impossible to tell where it originally came from. Thousands of years ago, when Oumuamua started to wander from its parent planetary system, the stars were in a different position, so it was impossible to pinpoint their origin. It could have been wandering the galaxy for billions of years, but how did the object find its way to our planet? Is there a way to stop it from crashing in our solar system? In 1837, an unknown object reached a notable cosmic milestone unnoticed by anyone. It crossed a distance of 1,000 astronomical units away from the Sun. For more than 100 years, this object kept advancing toward our Milky Way. Ironically, scientists never paid attention to it. It kept moving closer until October 19, 2017, when a scientist in Hawaii knew exactly what it was. On October 19, 2017, Pan-STARRS spotted an object moving rapidly. An image captured by a telescope at the University of Hawaii revealed a faint, thin streak traversing the sky consistently daily. This day marked a historical event as this was the first recorded interstellar visitor. The discoverer thought of the best name for the creature and decided to call it Oumuamua, meaning a messenger from afar. However, it was first named 1I/2017 U1 by the International Astronomical Union. Even though the discovery was made in Hawaii, the revelation sparked a global initiative to observe the object through telescopes. It also caught the interest of astronomers from SETI Institute, who eagerly engaged in observing the object. They also pushed the search further, hoping to find any extraterrestrial signs. This object might just feature some UFO. What does Oumuamua look like, you may ask? Some have described it as a reddish cigar-shaped rock object. Its elongated shape is almost 4 miles long and about 10 times longer than it is wide. Thus, this description surpasses any asteroid or comet in our solar system. Some still suggested that Oumuamua was either an asteroid or a comet. Oumuamua was traveling at a speed of 196,000 miles per hour. This means it is more than 100 times faster than a bullet. This shocking revelation again sets it apart from what we can identify in our solar system. Talking of it being an asteroid or comet, let's try to see the difference between the two phenomena. Comets are composed of ice, while asteroids are rocks. Scientists first thought Oumuamua was a comet but later changed their mind and called it an asteroid when it zipped past the Sun. But then they still held the notion of it being an asteroid until measurements indicated a slight acceleration, which means it might be a comet. However, there's a clause to this. Again, the object accelerated much more than they predicted. This situation puzzled the scientists. They were unable to determine what Oumuamua was. A remarkable characteristic of Oumuamua was its periodic brightening and dimming every 7.3 hours. This dynamic sign indicated its rotation around its short axis. Such a pattern adds to the fact that it might not be a comet. It suggested a more rigid and durable composition than most comets, typically fragile, snow-like material. It appeared dark red, similar to when moons in the outer solar system are affected by space radiation. Oumuamua's color might also involve iron, as Dr. Mech, an astronomer at the University of Hawaii Institute, suggested. Despite all these insights, the real definition of Oumuamua remains elusive. This led to the propositions of diverse theories, but will these theories help unravel the mystery? Scientific theories and observations. Various theories emerged to explain Oumuamua's identity. First, some believed it was a rock. Others proposed that it was filled with gas. But then some experts astonishingly said that Oumuamua must be an alien aircraft. This raises the question of whether an alien ship is somewhere hiding while dispatching smaller probes to explore the planets. But is that the truth? Let's dive deeper into the theories to find out more. According to Dr. Mech, Oumuamua must have been flung from a distant star following a supernova explosion. According to Elon Musk, it was formed when two objects collided and fused together. Astronomers were initially happy when they discovered that Oumuamua seemed to point toward Vega, the brightest star in the Lyra constellation. This star was known to possess a debris disk. By calculations, this object might have traveled to the present location in roughly 600,000 years. But then the possibility of it coming from Vega didn't hold much water. That's because significant changes were noted in its path. Astronomers believed that Oumuamua must have encountered a new star system for the first time. Considering its motion around the Sun, this was similar to the speed of nearby stars. Nonetheless, there's a possibility that Oumuamua must have been around the galaxy for billions of years. Scientists believe that Oumuamua is gaining momentum from the Sun, which propels it faster and in a different direction. Another theory worth noting suggests that Oumuamua is a chunk of nitrogen ice. According to researchers Alan Jackson and Stephen Desch from Arizona State University, Oumuamua might just be a fragment blown off a Pluto-like object by a massive impact. However, to merge with this theory, Oumuamua would have to be smaller than initially thought. Another theory proposes that cosmic rays interact with surface ice in interstellar space, freeing hydrogen gas trapped in water molecules. This created a supply of hydrogen gas trapped in amorphous water ice. This is the theory from Daryl Seligman, Cornell University, and Jennifer Bergner from Berkeley University. They suggested that Oumuamua gained warmth from the Sun, which altered the ice structure and pushed it forward. Well, this may be true only if it was truly ice. But that's not all. Astronomers Avi Loeb and Shmuel Bialy from Harvard University suggested that Oumuamua could be a solar-powered spacecraft. That sounds interesting. According to them, the various characteristics of Oumuamua suggest that it has an artificial origin, hinting at the possibility of extraterrestrial origin at play. This lends credence to the assumption that Oumuamua might be from an alien. No doubt the appearance of Oumuamua lends credence to the fact that it originated from a place outside our understanding of the solar system. However, we can't draw a final conclusion because its true size and shape remain a mystery. No device has been able to capture the actual image of this object. Astronomers only rely on its brightness and their knowledge of how asteroids and comets reflect light to guess the size. However, since no tail or coma had been found on the object, the comet theory was not approved. The comet theory also suggests that Oumuamua's apparent movement could be from the force that broke it free from a supposed parent object. However, repeated non-gravitational acceleration contradicts this assumption. In place of that, scientists coined a theory involving sunlight. If Oumuamua is extremely thin, around 0.3 to 0.9 millimeters, its movement could be due to solar radiation pressure. They proposed that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese probe and NASA's nanosail, D2. These light sails use photons' kinetic energy to propel themselves through space. Therefore, they suggest that Oumuamua could endure a long journey through interstellar space through a light sail. They estimated it could travel at least 16,000 light-years from its home system, wherever possible. Back to the idea of Oumuamua being an alien spacecraft, as pointed out earlier, some believe that Oumuamua was a spacecraft sent to examine our solar system. The unusual way that Oumuamua was found adds credence to these possibilities. Additionally, Oumuamua's motion closely aligns with a region of the Milky Way galaxy called the local standard of rest. This fact also makes it difficult to establish its origin. Well, it looks like we can't draw a final note on this just yet. So the question still lingers, what is Oumuamua? Who sent Oumuamua? A trip to Oumuamua. Scientists felt that they should send robotic probes with sails hurling toward Oumuamua. However, this suggestion isn't possible now, and that's because the world has not produced an aircraft that could take up such a mission. Well, maybe sometime in the future, as projects like Breakthrough Starshot are already building on this. Whether scientists reach Oumuamua or not, its visit can prepare the world for future encounters. Even though Oumuamua had taken billions of years to arrive at its current location, it's just a fleeting moment on the cosmic scale. The Milky Way galaxy boasts an age of 10 billion years. Therefore, Oumuamua could have journeyed through approximately 20,000 star systems. Well, this is a modest fraction compared to the galaxy's 200 billion stars. However, it's a good number of cosmic encounters for Oumuamua. It would have raised dust and debris, allowing the stars to intermingle. Therefore, Elon Musk and other astronomers believe that Oumuamua is on a fast race to the Earth. They had even predicted that it would enter the Kuiper Belt this year. Notwithstanding, no one has located Oumuamua. They only work on the information they can gather to determine its movement and possible arrival on Earth. And could that mean we should be expecting a blast in 2 weeks' time? Keep watching to find out. Oumuamua's trajectory. But there's more to say about Oumuamua's trajectory, which scientists termed unconventional. They observed a notable non-gravitational acceleration, indicating that forces beyond gravity are propelling its motion. Dr. Mech explained that several factors could lead to this acceleration. She then proposed 6 potential causes. The first observation was comet outgassing, which is a common occurrence in comets. Outgassing happens when a comet approaches the Sun and its surface ice sublimates, turning directly from solid to gas. This process gives the comet an additional push, altering its speed and rotation aside from the gravitational influence. The change in motion resembles the behavior of Oumuamua, aligning with the power observed in comets. As gas exits, a comet carries surface dust with it. However, Dr. Mech asserted that even if the comet lacked microscopic material, the potential presence of substantial dust on its surface might affect its speed. This consideration kept the idea of it being a comet alive, though only in terms of movement. Additionally, scientists observed viable wavelengths, which make it challenging to detect significant dust particles. Therefore, no visible evidence of dust leaving Oumuamua was observed. The absence of gas-related signs was also puzzling. Meanwhile, scientists and astronomers expected a significant amount of gas emission to influence Oumuamua's speed. Astronomers utilized the Spitzer Space Telescope to observe Oumuamua for over 30 hours, attempting to detect its thermal characteristics. However, they encountered challenges in their endeavors. Dr. Mech said that the observation, a thermal infrared test, detected heat emissions. In this case, their observation didn't yield any noticeable result. Interestingly, this fact can be detected even without any test. They concluded that Oumuamua might be brighter than anticipated if it exhibits thermal behaviors similar to a comet. An object's reflectivity, or how much light it reflects, can reveal details about its size, composition, and shape. Oumuamua is not what you think. Observations made within the short period of Oumuamua's visit soon proved that Oumuamua was on what astronomers call a hyperbolic orbit, a boomerang-shaped trajectory that indicated the rock was not native to our solar system but was only passing through the Sun's neighborhood and would never be seen again. But is this observation completely correct? Would Oumuamua never be seen again? An interesting phenomenon around Oumuamua is its speed, which seemed to increase as the rock rounded the Sun. Large bodies such as planets and stars can give smaller objects, including comets and asteroids, a gravitational kick that speeds them up. But in the case of Oumuamua, which at 54 miles per second, 87 kilometers per second, cruised 3 times faster than an average solar system comet, these gravitational kicks couldn't explain the observed acceleration. Remember, this is one of the theories that seem a hard nut to crack for scientists. Many scientists have tried to explain the mechanism behind Oumuamua's acceleration, but all of the proposed ideas have had significant gaps. In a new study, Jennifer Bergner, an assistant professor of chemistry at the University of California, Berkeley, and Daryl Seligman, a U.S. National Science Foundation postdoctoral fellow at Cornell University, propose a new theory that they think might finally put the issue to rest. At the time, it was such an amazing opportunity that I immediately dropped everything I was working on to work on Oumuamua, Seligman told Space.com. She's been trying to explain outgassing for several years. First, she thought the dust in the outgassing wasn't enough. Later, she thought it was made of some more volatile material than what they discovered in comets, such as hydrogen, nitrogen, and carbon monoxide. However, these explanations are subject to theoretical issues. Seligman said hydrogen, for example, would require extremely cold temperatures to freeze into objects the size of Oumuamua, and scientists don't expect such temperatures inside the dense molecular clouds where these objects form. He added that nitrogen is not ubiquitous enough in the Milky Way to account for the galaxy's expected number of such bodies.